If you travel across the plains and grasslands of western North America, you might see pronghorns blazing across the landscape at up to 55 miles an hour, the second fastest animal on the planet after the African cheetah. No cougar or bear or wolf can catch them, so their only threat is from humans who have guns. In fact, they're so common that hunting licenses for them are cheap in most states. To scientists, the American pronghorn is known as Antelope americana. It is found in the grasslands and prairies of the western half of North America, from southern Canada to northern Mexico. Native American cultures hunted them, and there are 330 different names for them, recorded from 219 different native languages. Pedro de Castaneda, who journaled Coronado's expedition in 1540, described them as a flock of goats that were so fast they disappeared very quickly. In 1776, Gabriel Maragall noted that they were called barrendos, a Spanish word meaning two-colored, the same name they have today in Mexico. In 1804, Lewis and Clark saw them somewhere along the Niobrara River and called them the goat-like antelopes. Although pronghorns are mentioned in a number of European bestiaries based on the Spanish accounts, they were not illustrated in European literature until the 1775 illustration in a volume by Johann Schreber. They're first formally described in 1815 by the American zoologist George Ord, first called it an antelope americana, but in 1818 he changed the name to antelope, which means goat antelope, the correct genus name today. The first common misconception is that pronghorns are antelopes. Nearly everyone but scientists calls them antelopes or pronghorn antelopes, for true antelopes live only in Africa and Asia and are members of the family Bovidae along with cattle, sheep, and goats. Pronghorns do resemble some African antelopes, but it's a classic example of convergent evolution. They occupied the ecological niche of antelopes in North America since true antelopes were never native to this continent. Both their anatomy and especially their DNA shows they are not close related to true antelopes at all, but are actually closer to giraffes among living mammal groups. Pronghorns are a strictly North American family that has never traveled to any other continent once they first arrived here from Asia about 21 million years ago. They were very diverse in this continent, with over a dozen genera known, sporting many different kinds of horns, and as many as 4 different genera even lasted to the end of the last ice age. Pronghorns have different kinds of headgear from the horns you find in bovines or the antlers in deer. All of these cranial appendages have a bony core, most of which are covered by a sheath of keratin, the same protein that makes up hair and nails and hoofs. Bovids have true horns, where the sheath is attached to a bony horny core permanently. Deer have antlers, which are made of a bony core covered by skin or velvet when they're growing. In the fall, the velvet is shed, and eventually the bucks shed their antlers as well, and they regrow them again the next spring. Giraffes have ossicones made of bony cores surrounded by skin. But pronghorns have something else, a bony core with a keratinous sheath that is shed every year. For fossil pronghorns, only the bony core is preserved, so we do not know what kind of sheath they might have had. And the earliest pronghorns, the myrmidons, appeared they grew a kind of velvet on their horns, but never shed them like deer antlers are shed. The bony horn cores is the most distinctive feature of most fossil pronghorns, what we use to recognize the genera and species, since their teeth and other anatomy is highly stereotyped and doesn't change very much. We have large quarry samples of horn cores of certain species of pronghorns that show how they grew. For example, these are all growth stages of Mauricudus from Verdigris Quarry in Nebraska, about 12 million years old. This image is a range of horns found in the 15-million-year-old Tonopah Formation of Nevada. Even though the teeth and jaws indicate only one species is present at this locality, the horns have been given names of several species in 2 different genera. We have addressed this problem of too many invalid genera and species being named for these primitive pronghorns, and evidence like this shows that horns are highly variable, and slight variations occur within normal population samples that can't be used to diagnose different species or genera. This image shows the range of variation of specimens of the living pronghorn, showing just how variable they are. This photo shows a modern pronghorn with 4 equal-sized horns, just like certain extinct species, so we must be very careful when we call a fossil a different species just because of small differences in horn cores. The females of living pronghorns are hornless, or have very small horns, but there's good evidence that many fossil species had horns in both males and females because no potential female skulls without horns are known. The first great radiation of pronghorns, from about 21 million years ago until about 10 million years ago, were the myrmidons, which are often the most common fossils in many localities from about 15 to 12 million years old. The Myrmidons include 4 and possibly 5 genera, with dozens of invalid genera and species that were in the literature until recently. These include the most primitive pronghorn, Paracosaurix, with long shafts of backward-pointing Y-shaped horns, the highly distinctive Merriamasaurus, with a palmate horn a bit like a tiny moose antler, and Ramosaurus, with multi-tined, deer-like horns that are often asymmetrical. And Mericidus and Cosaurix, which may or may not be distinct genera, since the length of the shaft of the horn varies continuously within populations. Both have horns shaped like a Y, with a shorter shaft found in Mericidus and a longer shaft found in Cosaurix. Myrmidons vanished about 12 million years ago, but in their place began a radiation of the genera of the antelocaprine pronghorns, ancestors of the living species. These began with Proantelocapra, with short hooked horns, Osbornoceros, with long curved horns like those of gazelles, Sphenophilus, with flat pointed horns, and Plioceros. One of the most distinctive was Illingoceros, which had long straight corkscrew horns. Haeoceros had short front horns and long back horns, while Stockoceros is a common Ice Age genus with equal-length pairs of horns on both sides. Even more bizarre is Hexamerix, with 6 horns, and Hexobelomerix, with a different configuration of 6 horns. The final lineage is Tetramerix, with really long back horns and tiny front horns, and the dwarf pronghorn Capramerix. It was the smallest of the 4 genera of Ice Age pronghorns, including Tetramerix, Stockoceros, and the living genus Antelocapra. Capramerix is particularly common in La Brea tar pits, where hundreds of specimens are known. So the pronghorn is the second fastest animal on Earth, with no predators in North America today that could catch them. Why do they need to be so fast? It turns out there was a predator in the Ice Ages, the American cheetah Miracinonyx, which probably hunted them and forced them to become extremely fast. That predator has vanished, but the speedy pronghorn lives on, an evolutionary anachronism. Pronghorns are a true American original, so much so that they are the official symbol of the American Society of Mammalogists. Only one species now remains of what was once a huge radiation of pronghorns, with as many as 4 genera roaming North America only 12,000 years ago.